Welcome to Basic Brewing Radio for Thursday, January 11th, 2007. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. Well, this week we delve into a fairly advanced topic, pH. What is it? How can we measure it? Does it matter? And how can we fix it if it's broke? The answers to all those questions and many more will be found in our conversation with John Palmer, author of How to Brew. A quick programming note. Yesterday I posted the latest episode of Basic Brewing Video where we head to Lyons, Colorado to get a tour of Oscar Blues Brewery with Dale, the namesake of Dale's Pale Ale. So it's a fun video, and you get to see the canning operation there, and they make some wonderful beers. And if you think that no good beer comes in cans, then try to get your hands on some Oscar Blues brews. It's just amazing. I had a couple last night, and it just made me sad that I'm not closer to them so I can get more. I want to keep my opening comments fairly short about this show because John and I talked for a good long time about our topic, but I do want to call your attention to a fundraising effort that's going on around the various beer-related podcasts. Linda Stark has been diagnosed with lung cancer. Linda has been with the American Homebrewers Association for a long time, I'm told. She's currently undergoing experimental treatments in Germany, and there's an effort going on to raise money to help pay for these treatments. Apparently, each treatment costs $15,000, according to a website that I was reading. So Craig and Jerry over at the Brew podcast are putting together sort of a celebrity six-pack with beers from them, John McKissick of Brew Crazy, Rick Hagerbomber from Big Foamy Head, Jamil Zainasheff from The Jamil Show, Charlie Papazian from, well, he doesn't have a show, but he's the reason we all do, basically, and me. I was honored to be invited to take part, and I've contributed one of the experimental all-grain, small-batch 4-pack IPA. It's an all-grain beer that I did on the stove. I was aiming for a 6-pack, but I only got 4. So it's more rare, more valuable, maybe. It's got tons of Amarillo hops, very tasty. And now there are only 2 left on the planet. So to find out how you can get in on a chance to win that beer, along with the other tasty brews, check out the Brew podcast. And I'll post a link in the description of this episode on basicbrewingradio.com to a page giving more details about Linda's situation. So I haven't met Linda, but good luck to her, and I look forward to the chance to meet her one day. Not very intimidating, by the way, putting one of my beers in with that crowd. I hope it measures up well, and I hope it does some good for Linda. And by the way, I also sent a 2007 Brewer's Logbook, defaced with my signature, to go along with the beer. So I've kind of upped my ante. So check out Brew Bubba's and up your ante. Well, that doesn't sound very nice, does it? Up your ante. Okay, before I do any more damage, let's get right into our topic for today. If you're new to the podcast and you're a new brewer, don't let the advanced nature of today's topic scare you away from the podcast. I think John does a great job of explaining pH in a basic way, but if you're not ready to think about it, check out our archives. There are plenty of episodes on more basic topics out there. However, in the interest of providing both the basics and the advanced, let's talk to John Palmer, author of How to Brew, about beer and pH. But John Palmer, welcome again to Basic Brewing Radio.
Oh, thank you very much, James. It's great to be here.
And you're broadcasting from the ping pong table in the garage.
Yes, I've been. These late night interviews have been banished to the garage. So,
of course, it's 2 hours later here than it is there. So you can't complain too much. But no, at least we're not on completely opposite coasts of the country.
That's right.
Now we talked a bit about water with Greg Noonan, and we addressed pH a bit. But I want to delve more deeply into the topic with you.
Okay.
And I guess the basic question to start out with is, what the heck is pH?
Okay. Yeah, the Greg Noonan show was a great show. I enjoyed listening to that one. And it really, a couple things I learned from him from hearing that was how important beer pH is. And, helping you zero in on a really good tasting beer. But, so what is pH? Well, it's the ratio of the anions to cations. It's also could be interpreted as the ratio of hardness to alkalinity in the water. pH actually stands for the logarithmic power of the hydrogen ion concentration in the water. And as you go down the scale, it's the negative logarithm. So as you go down the scale towards 1, the pH is more acidic. And that, in terms of brewing, we can liken that to the water being harder rather than alkaline, more acidic than alkaline. And a good way to just kind of think about pH is to think about it in terms of like two people on a seesaw. You put two people at different weights on the seesaw. That seesaw is kind of balanced between them, and one person is going to be high, one person is going to be low, and that can represent your pH number.
So the lower the number, the more toward acid you are.
That's right.
And
acidic.
The higher number, the more alkaline.
Right. Most people's water supply is between 7 and 9 on the pH scale, which represents a more alkaline condition rather than acid. And that's due to carbonates. And I'll get more into that in a couple minutes here. But what I want to tell everyone is that the concept of pH, is important to both extract and all grain brewers. It's something that every brewer can utilize. And like I said, Noonan Show did a really good job on talking about beer pH and how important it is for flavor and drinkability. He mentioned that beer pH should be between 3.8 and 4.3 or 4.5 at 25 degrees C. And the reason I say that at 25 degrees C is that pH is partly a chemical equilibrium. And so that equilibrium will shift depending on your temperature. Normally, when you're talking about pH, just like when you're talking about specific gravity, you're talking about measurements made at standard temperature and pressure conditions, so room temperature, in other words.
So beer is more acidic than water.
That's right.
And is it the grains that does that?
It's partly the grains, and it's partly the fermentation. Of course, your yeast, when they're fermenting, they are removing sugars from the solution and exhaling carbon dioxide. That carbon dioxide is in water, forms carbonic acid. And so that has a great deal to do with the reduction of pH in the beer.
It's interesting that you said that extract brewers have to worry about pH as well as all grain brewers. Yeah.
Extract brewers need to be aware that a lot of their brewing water is highly alkaline. And two states in the country that we can relate this to are Texas, especially near the Houston area, and Minnesota is another one. Northern Minnesota is on some limestone, and you can get a lot of carbonates in the water, and that can drive your alkalinity up above 200 parts per million. And if you brew an extract beer, which is take malt extract that's concentrated wort, the original minerals in the water that was used to make that wort have been concentrated down. So that's pretty minerally extract. And then you dilute that extract with high carbonate water. You end up with a very alkaline wort, relatively. And when I've judged beers, you will often come across one, American Pale Ale or an Amber Ale that has a very chalky, bitter taste. And I'm betting that a lot of times that's a result of doing an extract brew with an alkaline water. And these high carbonates make for a very dry, astringent bitterness in the beer.
So on the other side of the seesaw, what kind of tastes do you get if your alkaline or if your pH is too low?
Okay. Well, like I said, beer pH, you're looking for a beer pH that's between 3.8, 4.3. If the pH of the beer is below 3.7, two things. One, you're going to have a hard time clarifying that beer. It's just going to be hazy. It's not going to the yeast isn't going to want to flocculate. You're going to have a hard time clarifying it. And you can often get a metallic flavor. It gets so acid tasting and acrid that you can also get a metallic flavor that you'll taste. If the beer pH goes above 4.4, a little more alkaline, that's when you start getting soapy flavors from the hops and dull flavors from the malt. And that was one thing that Greg mentioned was that he said, don't worry about pH unless you have a problem. And I remember the question was, well, how do you know when you have a problem? And he says, dull flavors in your beer are one indicator of the problem. And I've tasted that many times. You'll taste someone's beer at a competition or one of your friends' home brews or even your own, and you'll think there's just something not lively, not bright in this beer. It's just kind of dull, and that's a result of the beer pH being a little too high.
Yeah, I was going to say that maybe the hop brightness is an indication that if the hops are dull tasting, maybe that's an indication that something is amiss with the pH.
Yeah, and he mentioned that too. Greg mentioned that too, where he said to add gypsum to your water to help brighten the hops. And as I'll talk a little bit later when we're talking about residual alkalinity in all grain brewing, adding gypsum to the water adds calcium to the water. In other words, adding hardness to the water and shifts your pH down and helps, in other words, add a little more acid to an otherwise high pH beer. So it's not only the sulfate sharpness or that can help bring out your hop character, but it also acts to drop the pH of the little beer too.
I've got a store-bought household water filter that I run my brewing water through. Is that going to affect my pH?
No. Most of the carbon filters that you can buy in the store, put on your tap, or even the whole house cartridge, and it's under the house and it goes to the little water tap on your sink, for purified drinking water. They're mostly activated carbon, and the carbon removes the organics from the water, the chlorine, the chloramine to a large extent, and the nitrates and other odors and all flavors. Some of the cartridges have resins in them that can help remove the heavy minerals like iron or manganese, and to some extent the calcium, or magnesium, but most home water filtration type systems really don't affect your water hardness or your alkalinity.
Now, what about water softeners? Say if you're on a well and you've got a water softener, does that affect the pH?
Yes, it does. The water softeners, they're a double whammy. Not only do they remove all your hardness ions, the calcium and magnesium, they also leave all of the alkalinity intact. So if you've got a hard water that's actually relatively balanced, in other words, two fat guys on the seesaw, and so, and you're trying to say, my water's so hard, I'm getting, carbonate scaling on my pipes, I'm gonna get a water softener. Well, you'll take the one fat guy off one side, but you still got the other fat guy on the other side, and that thing just goes boom, and it's really, really alkaline. So it's different if you got two kids on the seesaw and you knock one of them off. Now you just got that little kid there. That's kind of easy to manage. But when you've got a high alkaline water and you use a water softener on it, that water will be almost completely unusable for brewing.
So overall, is pH something to lose sleep over? I mean, or is this something that if you've got average water, you're just kind of tweaking?
Most people across the country have pretty average water, and they can brew American pale ales, amber ales, brown ales, and corresponding lager beers without much trouble. The brewing is a very forgiving process, so the pH will be ballpark most of the time. It's when you're living in Houston and you have highly alkaline water, or you're living in Portland and you've got very soft water or Pilsen-like water with almost no minerals at all in it. It's like snow melt, that you run into problems.
So how do we figure this out? I mean, how do we figure out if we've got pH issues? How do you measure pH?
Okay, well, there's a couple of ways. Probably the most accessible method for everybody is to use pH test papers. Now, you can buy these at aquarium stores and so on, and you've probably used them in chemistry class in school, litmus paper and so on. The problem with those is that they test pH with very broad strokes, 4 versus 5 versus 6, whereas for us brewers, we're interested in hitting, a half pH range of mash pH, anywhere from 5 to 5.5 or 5.3 to 5.8. That's where we're trying to control our mash pH. And in terms of the beer pH, like again, I said we're looking for something between 3.8 and 4.3. Again, a half pH unit difference. So your aquarium litmus papers are really not very useful. And so you think, okay, what's the next level? Hey, I can get a pH meter. I can get a digital pH meter. Well, nice idea. Very, very accurate. They cost, around $100, depending on which model you buy. What you also got to understand is that those things need constant maintenance. They have to be stored in calibration solutions and buffer solutions when they're not in use, and they have to be calibrated before each use. So you have to buy, in our case, as brewers, be looking for a pH 4 calibration solution and a pH 7 calibration solution. You'd run through the calibration procedure before using it, and even with good maintenance, an electrode is probably only good for about a year, maybe a year and a half, before that electrode gets contaminated or used up and needs to be replaced. So pH meters are good for a brewer that's brewing consistently every couple of weeks and willing to put that kind of time and effort into measuring pH.
It doesn't sound like me, though.
No, and me either. I've always wanted a pH meter, but I've never been able to bring myself to keep one up. So
it sounds like as much work as brewing. So
yeah. But there are a lot of people that have access to pH meters at work, and they can bring it home for the weekend and sneak it back to work, and no one's the wiser. But another alternative for a lot of people are test strips that are more accurate, and these are called color fast strips, and they're about $20, and they come in a box, and they measure pH in increments of 0.3.
And these are spelled color PHAST, right?
Right.
Color fast PHAST.
Right. They're available from several of the online brew shops like More Beer, Northern Brewer, and lots of shops carry them. They're very popular, and you can get them in scientific catalogs too. And those are pretty accurate. The color doesn't bleed. The thing you need to understand about pH strips is that these are most accurate at room temperature. So if you're in the middle of an all-grain mash and want to dip the strip in the mash itself, that's okay from the strip's point of view. It's not going to run or bleed. It's not going to put dye into your mash tun, but the pH shifts at mash temperature about 0.3 units. It goes 0.3 units lower, say from a reading of 5.8 at room temperature would measure 5.5 in the mash at mash temperature. But also the color indicators that they use on the test strips also change their reaction value at higher temperatures. So unless you have a table from the manufacturer in front of you and are able to take into account not only the pH shift in due to the temperature of the activity of the mash, but also the change in the indicator dye that's on the strip itself, and combine those and figure out what the real pH is, that's a lot of hassle. It's better to take a sample of the wort in a bowl, swirl it around, let it cool down to room temperature, or 80 or 90, where the error is pretty small compared to 150, and then dip the strip in the wort for a minute or two, take it out, and then compare it to the color chart. You'll get a much more accurate answer.
And then what's the target range that we're looking at?
Well, optimum mash pH at room temperature is 5.4 to 5.8. Now that's optimum. You can go a couple tenths either side, and you're still okay. Like I say, it's a robust process. If you were to measure that pH at mash temperature, the optimum range is actually 5.1 to 5.5 or 5.6, and that's the range that you most often hear quoted in books is 5.1 to 5.5, and this comes from de Klerk and other brewing scientists. But these days, with automatic temperature compensating pH meters and common laboratory practice, these are measured at room temperature, and all the latest data that you'll find in American Society of Brewing Chemists papers and so on, it's all conducted at room temperature, and the pH ranges they report are at room temperature, and so the optimum is 5.4 to 5.8.
And what happens if we talked about pH in relation to extract, but in the mash, if your pH is outside that range, how is that going to affect your beer?
If the pH of the mash falls below the optimum range by, say, half a pH value, from 5.4 at room temperature down to, say, 4.9, you're going to start affecting your beta amylase activity, and it's going to impair the beta amylase activity, and your conversion is going to suffer. And a good example of this is when you are brewing a dark beer, like a stout, or especially an imperial stout, but any porter, stout, or dark brown ale. When you're brewing that style of beer in water that is not very alkaline, and I'm talking anything from Pilsen or Portland, where just the mineral activity is very low in the water, to areas where the hardness and the alkalinity are pretty balanced, and that's probably a good chunk of the country. When you try to brew a very dark beer in those conditions, the dark malts are very acidic, and they will drive the pH below the optimum range, and it can affect your efficiency.
So it affects your efficiency. Could it also affect if you're messing with the beta amylase, could it affect the fermentability of the wort as well? Yes,
the wort will not be as fermentable because your beta has been impaired. So you're just going to get a lot of the larger chain sugars from the alpha amylase. And the other thing is that the stout will take on a very acrid taste because the beer pH kind of follows the wort pH or the mash pH. So if your initial mash pH is on the low end, your beer pH is going to end up on the low end, and vice versa. So that's another reason that pH is important for all brewers, is to understand this relationship. So what you start out with is your wort pH is going to follow through down to your beer pH. Yeah. And like I said, a stout can be very acrid because of that.
And what about the above the target range?
Okay, if the pH is above the range, and this is a situation that will affect a lot of brewers around the country, you're going to end up with the dull tasting beers because your mash pH was high. You're not going to have any brightness in the wort and the hop profile. Some of you could get some soapy taste. You can get some tannin extraction from your malts, depending on the degree of how high that mash pH is. All of this, as that beer ferments, is going to result in a beer pH that's on the high end, and you'll get dull flavors and, in extreme cases, astringent flavors in that beer.
So what do you do? So you get your fancy color fast papers, and you're out there and you cool the wort from the mash, and oh my goodness, you're outside the range, and if you're like me, you start to fret.
Yeah.
What do you do?
Okay, well this is where you get into the final frontier for many brewers is starting to understand water chemistry. And my mission in life, I think, is to try to explain this, because it's really not that bad.
You see, when you mention the word chemistry, I get flashbacks back to high school and Mr. Duncan's chemistry class, and all the figuring out the equations and the periodic table of the elements, and you start to lose me at that point.
Yeah, well, hopefully I can make this a little easier to understand.
You got to be better than Mr. Duncan. He was a nice guy, but a high school kid and even a patient instructor, not a good combination.
Okay, well, the way you handle pH and mash chemistry is the first thing you do is get your local water report. And on that water report, whether it's from the city or maybe from a well, you send a sample of water out to get tested, you want to know three things. You want to know your calcium concentration in parts per million or milligrams per liter. Same thing. Your magnesium concentration and your bicarbonate concentration. Now, I say bicarbonate because for most people around the country and around the world, their water pH is going to be between 7 and 9. and a lot of them it's going to be between 7 and 8.3. And in that region, your bicarbonate is the dominant alkalinity ion. An equivalent measure of alkalinity is the total alkalinity as calcium carbonate, or CaCO3. And you'll see that quantity listed on water reports very, very often. It says total alkalinity is calcium carbonate, and you'll probably see total hardness is calcium carbonate. The reason they say as calcium carbonate is they measure these chemically in terms of equivalence, an equivalence of hydroxide necessary to reach a certain pH. I won't go into that chemistry, but in my book, in chapter 15, in How to Brew, I explain what the conversion numbers are, what they mean, and what I want to talk about today is, how do you actually use this information? You're going to take your calcium, your magnesium, and your alkalinity, and you're going to calculate the residual alkalinity. And that is simply you take this total alkalinity number and subtract from it your effective hardness. And I say effective hardness because this is not total hardness from the water report. It is, you take the calcium concentration and divide it by 3.5. You take the magnesium concentration and divide it by 7. And then you take that quantity of effective hardness and subtract it from the alkalinity. This is your residual alkalinity. And it's this quantity that determines your mash pH along with the grain bill that you're mashing. And in my book, How to Brew, I've got a nomograph in the back where you can plot these on scales, and then it points to what I call the base malt mash pH scale. The two are side by side. You'll point to your residual alkalinity number and the corresponding base malt mash pH. My number one question that I get on emails from people that are trying to understand Chapter 15 is, I put in my numbers and I get a mash pH of 6. Are you saying that I want a mash pH of 6 to brew a dark beer? And the answer is no, you don't. You always want a mash pH of 5.4 to 5.8. Higher, the scale in the nomograph is talking about base malt only. So if you took, pure base malt, lager malt, pilsen malt, mashed that with no specialty grains, and you put it in that water with the residual alkalinity of, what's the number here? 150 to 200. If you mash base malt only into that kind of water, the mash pH would be about 6, which is too high.
Mm-hmm.
And you would start getting the dull flavors, and you wouldn't get good brightness in the beer. If you calculated the residual alkalinity and it came out at 0, which is quite common for a lot of the country, that corresponds to a mash pH of about 5.7, base malt only. And in other words, for a lot of the world, you can take, moderate alkalinity water and just base malt and brew a light beer, a pale ale, a pilsner, a pale lager, and the mash pH will come out right, which makes sense historically. I mean, we've been brewing beer for 5,000 years without knowing what pH was. It had to work. One thing I need to caution everyone about using the nomograph is that while the residual alkalinity calculation is based on solid science, that science was conducted in the 40s and 50s by a German brewing scientist, and The malts that they had then are not quite the same as the malts we have now. And the color scale that I've placed above the nomograph to indicate, what style of beer is most suitable for a certain level of residual alkalinity, that's an approximation. That's based on my experience and the experience of other, modern homebrewers, and a lot of arm waving, saying that residual alkalinity of 200 parts per million equates to Ireland, and to Guinness Stout, residual alkalinity of 40 equates to Dortmunder and Pilsen and pale beer brewing cities. So a lot of arm waving went into that color scale. So if you're trying to brew a stout and you're looking on the spreadsheet, and the spreadsheet's estimating say a 25 SRM darkness number, and ProMash tells you that the darkness of your recipe should be 40, don't try to overshoot and add more alkalinity to get something that's closer to a 40 interpretation on that scale. Go with the 25. Be a little conservative, because that color scale is an approximation, so it's not gospel. That's what I want to emphasize. So
okay, your mileage may vary.
Yes, that's a very good way to put it. And that's another thing. When you get your local water reports from the city, those are annual averages. So the calcium, magnesium, alkalinity numbers that they report is just an annual average, and your water supply may vary in its hardness and alkalinity with the time of year. Some cities pull from the river during the winter months, or from wells deep wells during the winter, and pull from the river during the summer. So there can be a real shift in the water composition with the season, and that's another thing to be aware of too. So, but what the concept of residual alkalinity allows you to do is judge what kind of beer, what darkness level of beer your water is most suited for. And Chapter 15 goes into the nuts and bolts of how to control that, so that if you live in Portland and you want to brew a dark beer, it can guide you to approximately how much alkalinity to add to your water, to your mash, to get the pH to be in the optimum range. And likewise, if you live in Houston and you want to brew a light beer, it can guide you to how much either acid or equivalent hardness from calcium, gypsum, that you want to add to the mash, to the water, to get the mash pH in the optimum range.
So what kind of additives are we talking about?
Well, there's a lot you can use. Gypsum calcium sulfate is the most common one, and from Charlie Papazian's, Complete Joy of Home Brewing, where he suggests adding gypsum to most every recipe. That works. That worked for his area, for the water he was brewing with. It helped. That calcium helped overcome the residual alkalinity of his water to brew the majority of the beer styles he was working with. And Greg Noonan said much the same thing. You can add gypsum or calcium to your water to help brighten the beer. Other areas where you're trying to increase the alkalinity, you want to use calcium carbonate. Now you say, well, I thought calcium was for lowering the pH. In the case of calcium carbonate, the carbonate half of that mineral is stronger than the calcium side. It does add to the acidity, but it also is heavier on the alkalinity side. So the net effect of adding calcium carbonate to your mash is to raise the pH.
What if you need to lower your pH?
Well, lowering the pH, like I said, you can use the calcium carbonate or calcium sulfate, gypsum. You can use calcium chloride. You can also use acids, such as phosphoric, lactic, sulfuric, hydrochloric. Any of these acids will help lower the mash pH. Sulfuric I don't recommend because it is just too aggressive to skin. It's just a little too dangerous to work with outside of a laboratory.
And we're making food here, so, you know.
Yeah, well, actually, sulfuric is perfect from a brewer's point of view. What you're doing is you're adding sulfate, which, you know, only helps your hops unless you're adding tons of it. But you really don't need. Usually, for most mashes, you're only talking about maybe 5 milliliters to the whole mash. It's a very small amount.
But you don't buy it in containers of 5 milliliters.
No, you have to get a 2-gallon jug, which makes handling dangerous. Hydrochloric is nice because you can get hydrochloric at pool supply places. Muriatic acid is hydrochloric acid, and that's people are used to handling hydrochloric acid, and it's not as aggressive to skin as sulfuric is. So even though it's a strong acid, it's a little easier to handle. And there's calculations. If you go to my website, howtobrew.com, in the Chapter 15 area, there's a spreadsheet, an Excel spreadsheet on the bottom of the page that can help you calculate acid additions to adjust the residual alkalinity.
Now, 5 Star Chemicals, the manufacturer of Star San, they have a product called, is it 5.4?
5.2.
5.2.
Yep.
Do you have any experience with that?
Yeah. I've used it. It's a good product. It really is. It's a good product for most of the country, most of the time. And not to detract from 5 Star at all, it's a product that I would have. I mean, that, you know, if I had addressed myself to how can I help brewers, you know, solve this problem of attaining mash pH, I would have come up with the same solution. The problem is, you know, when you're dealing with the wide range of beer styles, malt acidities, water chemistries around the country and around the world, you know, you're looking at kind of like, you know, your bell curve. You're looking at 5.2 can handle 90% of the situations, but there's always those people out on the fringes where it's not going to help, or at least it won't fully solve the problem, and they're going to say, it didn't work. Well, it's because you are out on the, you know, ragged edge of brewing capability with the style of beer that you're trying to brew and the brewing water that you're using. So anybody with extremely high alkalinity, you know, 200 parts per million and above, 5.2 is going to have a hard time bringing it down. If you're brewing a very dark beer with Portland or Pilsen water, 5.2 is going to have a hard time bringing the pH up to the optimum range. It's going to probably be on the low end.
Huh.
So, you know, it's a good product and it does the job for most of the people most of the time. But when you're talking about an extreme brewing situation, dark beers with very soft water or pale beers with very hard or very alkaline water, it's going to have a hard time doing the job fully. So just a little caveat there, but otherwise good product.
Well, good. That's good to know. Like I told Greg Noonan, I haven't messed with water chemistry much because I'm pretty happy with the beers that I'm brewing, and it is an intimidating topic, you know, especially when you get to talking about chemistry and these elements and the minerals and such. It really does take some thinking to get around it.
Yeah. Well, there's been a couple of practical examples in the past year. I was on the Green Board, the Homebrewing Adventures Green Board forum, and a gentleman in Minnesota was having a hard time brewing pale beers. He said they always took on a house flavor, and he posted his water report, and he was in a very high alkalinity area, so he was having a hard time with that very alkaline water brewing a good pale beer. And the suggestions from myself and several other people on the forum was to start out with reverse osmosis water, that is, demineralized water, and add certain levels of minerals to it that resulted in a residual alkalinity that matched the color of the style of beer he wanted to brew. He brewed it, and he was astonished. His yield went up 15 points.
Wow.
I gave this water talk in Fargo, North Dakota for their Hoppy Halloween competition this past year. And I went over these calculations and how to use the nomograph. And the next day on Sunday, we went over to Vince Rock's house he was doing a Christmas brew, doing an American stout. And he said after watching my presentation, he went home and reworked his recipe, and he calculated that he needed to add 1 teaspoon per gallon of sodium bicarbonate to raise the alkalinity of his water to brew this dark stout. And he said, according to his brewing efficiency, typically, he usually got somewhere around 73% efficiency or 73% yield. The next morning when we brewed that recipe, he got 83% yield. So, and that's a case of where, if he hadn't added alkalinity to the water, the dark malts in that recipe would have driven the pH low and impaired the beta amylase. By adding sodium bicarbonate or baking soda to the mashed water, it raised that pH to the optimum range, and you got a 10% increase in yield.
Wow!
And I tasted the beer. He sent me a bottle. He was kind enough to send me a bottle. Very smooth beer, very good tasting American stout. So this is. Residual alkalinity and pH is a real thing. It can really help you.
You can't argue with success, I guess.
Yeah, I hope tonight that I've been able to talk about it in a straightforward manner without circling around, going off on tangents. But I think it really can help people brew better beer, and hopefully. Both in this talk and in the book, I've managed to make it fairly straightforward. So it's something that you can play with and experiment with, and you don't have to get down into all the nuts and bolts of it. What I wanted to say is that if you just take the concept far enough to understand what your water is probably best suited for, then you'll have much more satisfaction as an all-grain brewer, because the beers will come out tasting right. They won't come out tasting wrong.
Well, I now have a New Year's resolution, John. I've just now resolved to take a look at my water more closely and to get into chapter 15 and see how I'm doing, see if I can increase my efficiencies, increase the flavors of my beers a little bit.
Well, good. I hope this helps. One thing I wanted to mention was that if you're on a well, or if you get your water report from the city and it doesn't have the mineral information that you want on it, you can send a sample of your water. Say, like if you use like a pint water bottle, send that to a place called Ward Labs in Minnesota. And go to wardlab.com, not labs, but lab, singular. And for $15, they will test that water for you and report back on all the minerals that you need to know. It's called the W6 Household Mineral Test.
Oh, well, there you go. And any questions on this topic that we've covered in the show, go to howtobrew.com and find John's email address because I'm not going to know.
No, I'm happy to help people with this topic. it can be a little daunting, and even people that have read Chapter 15 3 times will still ask questions, and I'm happy to answer them, because once you get it to click, people say, now I understand what I need to do, and I understand when I need to be worried about pH and when it's not a problem.
Well, great. I appreciate your being a resource for us all, and I appreciate your being a recurring guest on this show.
I'm happy to do it. I'm just a brewer like y'all, and I'm looking on that eternal quest for good beer.
Well, thanks, John.
Thank you.
Thanks again to John Palmer. It's always fun and interesting to talk to John. I just think it's fun to talk to people who know more than I do on various topics. Needless to say, that's a pretty wide field. You can find John's website at howtobrew.com. I want to say that I officially broke in my copy of our 2007 Brewer's Logbook this past weekend. I took my Belgian blonde recipe and I used a bottle of the dark candy syrup that we talked about in our Belgian sugar show. So I'm calling this beer a Belgian brunette. And it's happily bubbling in the primary carboy as I speak. I think the Brewer's Logbook will help me a lot in getting organized on my brewing. I used the calendar in the front to document when I brewed and when I moved the beer from the basement to the upstairs to warm it up a little bit. I also documented the details of the brew session and the fermentation temperatures and all kinds of stuff. So thanks to everybody, by the way, who's picked up a copy of the logbook from our basicbrewing.com site. I look forward to hearing your comments on the layout and how we can make it better for next year. So if you haven't got one yet, you might want to check it out before the year gets away from us so you can start documenting your brews for 2007. Next week, we'll talk to a couple of Northwest Arkansas brewers who are working to establish a gluten-free brewery. We'll sample a couple of their brews and get some tips on brewing gluten-free at home, and also why you might want to do that. If you have brewing questions, show suggestions, or just want to say howdy, write to james@basicbrewing.com, or just fill out the contact form on basicbrewing.com, and please don't forget to tell us where you're from, and please check your email address to make sure that you've typed it in correctly. Otherwise, I can't get back to you. I have no clue. And while you're on our site, you can check out our online shop, where you can find great pricing on our DVDs and a combo deal to save you even more. In our first DVD, Introduction to Extract Home Brewing, we walk you through the extract brewing process step by step from boiling to bottling. And in Basic Brewing, Stepping into All Grain, we take you through the all grain process from milling your grain to collecting your wort. It's easy once you know how, and we'll show you how. You can see a listing of the fine folks across the country who sell our DVDs on basicbrewing.com. And if there isn't a vendor in your area, you can order it from us directly online. And I'll box it up my own self and maybe get one of my kids to put some labels on it and such. So, also, don't forget the Brewer's Logbook. So, thanks to everybody who's continued to click on our Amazon.com link. We appreciate the support. Anything else? No, I don't think so. I think that's it. That's all. Until next week. Until then, thanks for listening, everybody. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by Kelly Dotson, our friend in Austin, who also designed our logo. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. So long.